Hey guys, the objective of this video is to understand and derive integration by parts. So this now is a second integration technique. So we've so far learnt integration by substitution. This is technique number 2, integration by parts, to deal with more complicated integrals. So it's derived from the product rule. So hopefully you guys remember the product rule, which says that DDX of f of x, g of x, so the product of two functions, is equal to f dash of x times g of x plus f of x, g dash of x. I like to think of it in a more simple term. I like to think of it as ddx of uv, where u and v are just functions, is equal to u dash v plus v dash u. Okay, hopefully you might be more familiar with this type of one. I'm going to be using that. So all we do is we literally just rearrange it to get v dash u, so that term there, we're making that the subject, by subtracting that to the other side, so ddx of uv minus u dash v. I'm just going to write this now as u v dash, so it's v dash u v dash is the same thing. I've just rearranged those two letters, and now we're going to integrate every single term. If we do that, we have the integral of uv dash equals uv, because an integral times a differential cancel each other out, so we're left with a uv minus the integral of u dash v. Okay, so that essentially is the integration by parts. It might look very confusing as what this all is now. We're going to be doing some examples in the next video where we'll go through it so it makes sense. Essentially, what you're going to be looking for is going to be when you have two functions multiplied by each other,